A very good morning, dear students. Today we will see the definition and classification of carbohydrates. Okay, what are carbohydrates? In olden days, carbohydrates are defined as hydrates of carbon with an empirical formula CH2O raised to N. Okay. It was an older definition, hydrates of carbon. But lactic acid, acetic acid, having the empirical formula of CH2O raised to 3 and CH2O raised to 2. They satisfy this formula, but they are not considered as carbohydrates. Okay. Similarly, deoxyribose. It deviates from this equation, but it is considered as a major sugar, carbohydrate. Okay. So, nowadays, the definition of carbohydrate is different. That is, carbohydrates are polyhydroxyaldehydes or ketones or compounds which obtain them or produce them on hydrolysis are termed as carbohydrates. So, carbohydrates are polyhydroxyaldehydes or ketones or compounds which produce them on hydrolysis. Now, that type of compounds which obtain them on hydrolysis are termed as carbohydrates. So, carbohydrates are polyhydroxyaldehydes or ketones or compounds which produce them on hydrolysis are termed as carbohydrates. Polyhydroxy means it contains more than one hydroxy groups. Okay. Then, coming to the classification of carbohydrates, they are classified as monosaccharides, disaccharides, oligosaccharides, and polysaccharides. So, carbohydrates are classified into four. They are monosaccharides, disaccharides, oligosaccharides, and polysaccharides. Then, monosaccharides. Monosaccharides means it is the simplest form of carbohydrates. That means it cannot be further hydrolyzed into its simpler forms. Therefore, we can consider it as monomeric units. Monomeric units of carbohydrates. They are monosaccharides. Then disaccharides means it contains two monosaccharide units. Two monosaccharide units. Then oligosaccharide means it contains 3 to 10 monosaccharides or monomeric units. Then polysaccharide means it contains more than 10 units. More than 10 units. Okay. So, carbohydrates are classified into monosaccharides, disaccharides, oligosaccharides, and polysaccharides. Monosaccharides means it contains only it is the simplest form of carbohydrates which cannot be further hydrolyzed into its simpler forms. Or it contains only a monomer. Then disaccharide means it contains two monomeric units or two monosaccharides. And oligosaccharide means it contains 3 to 10 monomers or monosaccharides. Then polysaccharide means it contains more than 10 units. Okay. Then coming to monosaccharides, it is further classified into trioses, tetroses, pentoses, hexoses, and heptoses. This classification is according to the number of carbon atoms. Monosaccharides are further classified into trioses, tetroses, pentoses, hexoses, and heptoses. Trioses, which contains 3 carbon atoms, tetroses contains 4 carbon atoms, pentose contains 5 carbon atoms, hexose contains 6 carbon atoms, and heptose contains 7 carbon atoms. And according to the functional group present, it is further classified into aldoses and ketoses. Aldoses means the monomeric unit contains an aldehyde group. Ketosis means the monomeric unit contains a ketone group. Then we can write some examples for this triose. Triose means aldose, ketose. See, glyceraldehyde. Glyceraldehyde is a triose which contains an aldehyde group. So it is an aldose. Then ketose. Ketose, it is dihydroxy acetone. Corresponding 3 carbon ketone is dihydroxy acetone. That is a ketose because it contains a ketone group. Then for tetroses, it is erythrose. Erythrose contains aldehyde group, so it is an aldose. Then erythrulose. Erythrulose, which contains a ketone group, that is a ketose. Then pentoses, example is ribose. Ribose contains an aldehyde group, and the corresponding ketose is ribulose. Then example hexose is most common, glucose, and the corresponding ketone is fructose. Then heptose, it is glucoheptose. Glucoheptose contains an aldehyde group, and corresponding ketose is pseudoheptulose. So, according to the number of carbon atoms, monosaccharides are further classified into triose, tetrose, pentose, hexose, and heptose. 3 carbon, 4 carbon, 5 carbon, 6 carbon, and 7 carbon. So, according to the functional group present, it is further classified into aldose and ketose. Aldose means it contains an aldehyde group. Ketose means it contains a ketone group. See, example for triose is glyceraldehyde, that is an aldose which contains an aldehyde group. The corresponding ketose is dihydroxyacetone. For example, for tetrose, it is erythrose. The corresponding ketose is erythrulose. Then, for example of pentose, ribose, corresponding ketose is ribulose. 6 carbon carbon or hexose is glucose, corresponding ketose is fructose. 7 carbon carbon, it is heptose. Example for an aldose is glucoheptose, corresponding ketose is pseudoheptulose. Okay. Then coming to the disaccharides, it contains 2 monosaccharide units by glycosidic linkages. By glycosidic linkages, 2 monomeric units are combined to form disaccharides. Example for is lactose. Lactose then maltose and sucrose. These are some examples for disaccharides. This is further classified into reducing and non-reducing. Reducing and non-reducing. Examples for reducing disaccharides are lactose and maltose. For non-reducing disaccharide is sucrose. Lactose contains a galactose unit, a 6-carbon galactose unit plus a glucose unit. Maltose contains 2 units of glucose. Glucose plus glucose. Glucose plus glucose. But sucrose contains a glucose unit plus a fructose unit. Galactose plus glucose are formed by beta 1,4 glycosidic linkages. Maltose is formed by alpha 1,4 glycosidic linkages, and sucrose is formed by alpha 1 and beta 2 glycosidic linkages. So this is about disaccharides. Disaccharides are further classified into reducing and non-reducing. Example for reducing disaccharides is lactose and maltose, and for non-reducing disaccharide it is sucrose. Lactose is a molecule which contains 2 monomeric units. One is galactose and one is glucose. Maltose, which contains a single unit of glucose, 2 molecules of glucose, and sucrose, which contains a glucose and a fructose unit. See, this is non-reducing because alpha 1 and alpha 2 carbon are involved in glycosidic linkages. This in alpha 1 and beta 2 of alpha 1 of glucose and beta 2 of fructose contains the functional group. They are linked together to form glycosidic linkages. So it will not reduce. It will not act as a reducing sugar. Okay. Then coming to oligosaccharides. Example for oligosaccharides is, oligosaccharide means it contains 3 to 10 units of monomeric units. Raffinose, example is raffinose and stachyose. Raffinose contains 3 monomeric units, one galactose, one glucose, and one fructose. One galactose plus glucose plus fructose. Stachyose, which contains 4 monomeric units, that is 2 units of galactose, 2 units of galactose plus 1 glucose plus 1 fructose. That is stachyose. They are the example for oligosaccharides. Then coming to the polysaccharides. Polysaccharide means it contains more than 10 units of monosaccharide. It is further classified into homopolysaccharide and heteropolysaccharide. Homopolysaccharides, and heteropolysaccharides. Homopolysaccharide means the constituent monomers are same. For example, glucose. It is linked together means the monomers are same. Here in heteropolysaccharide, the monomers will be different. Monomers are different. The monomers are different in heteropolysaccharide, but the monomers are similar in polysaccharide. We will see the examples for homopolysaccharide. It is starch. We might have heard of starch. It is made up of amylose and amylopectin, which composed of glucose. The amylose as well as amylopectin. Amylopectin is derived of glucose. The linear linkages are formed by alpha 1,4 linkages, and branching is formed by alpha 1,6 linkages. Cellulose contains, in plant cell wall, it contains beta 1,4 glycosidic linkages. Human enzymes cannot digest this cellulose. Therefore, cellulose is used for increasing the bulk of stool, and it can be used for relieving constipation. Then dextrin, it is a partial degradation product of starch. Partial degradation product of starch. Partial degradation product of starch. And dextran, it is a plasma expander. It is used as a plasma expander. Plasma expander. Then inulin. Inulin is used for measuring glomerular filtration rate. It is an important homopolysaccharide which is used for measuring glomerular filtration rate. Then chitin, which is present in exoskeleton of insects. Exoskeleton of insects. These are some of the homopolysaccharides: starch, glycogen, cellulose, dextrin, dextran, inulin, and chitin. So we must remember, starch is a plant storage form of glucose. Glycogen, which is animal storage form of glucose, and cellulose, which is present in plant cell wall, contains beta 1,4 linkages, and human enzymes cannot degrade cellulose. Then dextrin. Dextrin is a partial degradation product of starch, and then dextran, it is a plasma expander. Then inulin, it is used for measuring glomerular filtration rate, and chitin, it is an exoskeleton. Here, inulin is a polymer of fructose. That is one thing to remember. Inulin is a polymer of fructose which is used for glomerular filtration rate. Then coming to heteropolysaccharide, it is otherwise known as glycosaminoglycans. Glycosaminoglycans or mucopolysaccharides. Mucopolysaccharides. Some of the examples are agar, agarose, hyaluronic acid, then heparin, then chondroitin sulfate, then dermatan sulfate, then keratin sulfate, These are some of the heteropolysaccharides. These are otherwise known as mucopolysaccharides. It is mucus-like materials. It carries a negative charge. Therefore, it repels each other. So it acts as a shock absorbent. Okay. So examples are agar, agarose, hyaluronic acid, heparin, chondroitin sulfate, dermatan sulfate, and keratin sulfate. Then these are used for, agar is used as a suspending agent. Then hyaluronic acid, it is present in synovial fluid and replacement of eye. Then heparin, it is an anticoagulant. Then chondroitin sulfate in tendons and cartilages. Dermatan sulfate is present in skin and walls of blood vessels. Then keratin sulfate is present in cornea of eye. Okay. So homopolysaccharide which contains monomeric units, and heteropolysaccharide which contains different monomeric units. Some of the examples are starch, glycogen, cellulose, dextran, inulin, and chitin. Examples of heteropolysaccharides are agar, agarose, hyaluronic acid, heparin, chondroitin sulfate, dermatan sulfate, and keratin sulfate. Okay, so carbohydrates are classified into monohydrates, monosaccharides, disaccharides, oligosaccharides and polysaccharides. Monosaccharide means it is monomeric units. On further hydrolysis, it cannot be degraded. Means it cannot be further degraded into simpler carbohydrates. Okay. Then disaccharide means it contains 2 monomeric units. Then oligosaccharide means it contains 3 to 10 monomeric units. Then polysaccharide means it contains more than 10 monomeric units. Monosaccharides are further classified into triose, tetrose, pentose, heptose and heptose according to the number of carbon atoms, and according to the functional group present it is further classified into aldehydes and ketones. Then disaccharide is further classified into reducing and non-reducing oligosaccharides. Then polysaccharides are further classified into homopolysaccharides and heteropolysaccharides. See, then now we will go for the functions of carbohydrate. The functions of carbohydrates, we must remember the examples. Glucose, for example, glucose, it is the energy provider of human body. It contains 4 kilocalories per gram energy. Then sucrose, it is a table sugar. Then starch, we will say examples for polysaccharides. Starch, it is a human animal storage, plant storage form of glucose, like the animal storage form of glucose. Cellulose present in animal plant cell one. Then next degradation product of starch. Next plasma expander, ingredient used to lower blood pressure rate, chitin. It is present in exoskeleton of insects. Then agar, which is a suspending agent. Then hyaluronic acid present in synovial fluid. Heparin, it is used as an anticoagulant. Then chondroit itself is tendons and cartilages and bones. Then dermatoid sulfate is present in skin, walls and blood vessels. Keratin sulfate is present in cornea. So, see, by remembering the examples of starch or examples of carbohydrates, we can write the functions of carbohydrates. And this is all about the definition, classification and functions of carbohydrates. Okay, thank you.